Okay, want to look at another example on quadratic inequalities. This will be the example 2. I've done example 1 and I've uploaded it to my YouTube channel. So still on quadratic inequalities, it's always an issue for students. So what you do here, they said solve x squared minus x minus 6 greater than 0. It means find the range of values that will satisfy this particular quadratic inequality. What you should do is first solve like a quadratic equation. So rewrite it this way. So you have x squared minus x minus 6 is equal to 0. See, I've changed the sign to equal to the equal sign. So then you solve by, you could use factorization method to make our work very easy. So we just have x squared, then replacing minus x with minus 3x plus 2x, then continue with your minus 6, then equals 0. Then you now factorize, you pick them in twos, you pick these two values and these two values and find their common factors. And so let's try it here. This will be the common factor, the highest common factor here will be x, open bracket, x squared cancels, x squared divided by x gives you x, then minus divided by the plus here gives you minus, 3x divided by x gives you 3, then you close the bracket, and here I have plus, then I have 2x and 6. What's my highest common factor here? It will be 2 because the x is not common on both sides. Then open your bracket, 2x divided by 2 leaves you with only 2, leaves you with only x rather. Then minus divided by plus is minus. Then 6 divided by 2 gives you 3. Then close your bracket, then equals 0. Then you notice that these two and these two, this one and this one, they are common. This is x minus 3 and this is x minus 3. So you pick out one of them, minus 3, like you're factoring it out again. And then notice your x and plus 2 outside. That's one of the factors again. So you combine it with this one, in product with this one. So x plus 2 also stands in here, x plus 2, then equals 0. And of course, if this times this gives 0, it means one of them is 0. So it's either one, it means one of them is equal to 0. So that's either x minus 3 equals 0 or x plus 2 equals 0. So I will end up having x equals 3 here if minus 3 moves over, and here x equals minus 2. So now this is where the problem starts from, because now we have to draw a number line, and drawing your number line you have it this way. So then your 0 is always your demarcation, then you fix your minus 2. So draw your demarcation here, and we are not shading because we are not including the minus 2 in the range of values. Minus 2 is excluded according to the question. They just wrote greater than, but did not put equal to. Not if it's greater than or equal to, when we shade the small circle here. So likewise here also, 3 stays here. Positive numbers are always on the right hand side of the 0, and then we draw a line to show that this is a region. We are not shading also, of course you know why. This is just greater than and not equal to. So the issue here is, am I drawing an arrow to the left or to the right? Then on this part to the right or the left, and you might assume, oh, since the equality sign here is greater than and is facing the right, the pointer is facing the right, I should just draw my arrow and assume that the range of values here will make the inequality true. But that will be wrong. What you have to do is to test and know which of the range of values will make the inequality true. So I will test a particular number on this region, although there are many numbers here, and we have minus 3, minus 4, minus 5, minus 100, and so on this region, the left hand side of this minus 2. I'll just pick one of them, which is minus 3, and see if it will work out for me. So picking minus 3, I'll fix it into the inequality to see if it will make it true. If it makes it true, it means that the range of values here, minus 4, minus 5, minus 6, will also make the inequality true. Then I will be able to draw my arrow here. And I'll also come here and pick 4 or 5 or 6. Just pick any of the values that are on the right hand side of 3 and fix into this quadratic inequality to see if it will make it true. If it makes it true, it means that every other number here will work out. 4, 5, 6, 700, 1000 will also make the inequality true, and it means I can draw my arrow this way. And I will also test here because I won't leave this region out, because I have 1, 2, 0, minus 1, and so on here on this region. So I could pick 0 to see if it will work out. If 0 makes the inequality true, it means every other number in this region will make the inequality true, and then I can draw my line here to show that the regions here make the inequality true. Okay, so now let me test minus 3 first. So test for minus 3. So test for minus 3. Test for minus 3. So I'll fix minus 3 into the quadratic inequality. So I have x squared minus x minus 6 is greater than 0. So anywhere there's x, I'm putting minus 3. So here will be minus 3 squared bracket minus open bracket minus 3 close bracket minus 6 is greater than 0. So this one will now be 9. Minus 3 raised by 2 is minus 3 times minus 3. This will be 9. Minus times minus is plus. Then you write your 3. Then minus 6 is greater than 0. Then 9 plus 3 is 12. Minus 6 is greater than 0. Then 12 minus 6 is 6 greater than 0. Is this true that 6 is greater than 0? Definitely it is true. So that means since minus 3 made the inequality true, minus 4, minus 5, minus 6, and so on, all the numbers within this region will also make the inequality true. I can now happily draw my arrow on this side of the number line. So on this other side of the number line, I'm going to test 4 to see if it will make the inequality true. So test for 4. So write up my x squared minus x minus 6 is greater than 0. So anyway, there's x, I'm putting 4 there. So this one will be 4 squared minus 4 minus 6 is greater than 0. 4 squared is 16. So that's 16 minus 4 minus 6 is greater than 0. 16 minus 4 is 12. 12 minus 6 is greater than 0. 6 is greater than 0. Is it true that 6 is greater than 0? Yes, it is true. That means the 4 I picked from here worked out, and it means every other number on this region, 4, 5, 6, 7, 8, 9, 10 to infinity, will also work out and make the quadratic inequality true. And that means I can draw my arrow here to show you that it is true that numbers on this region will work out. Yeah, let me just playfully test 0. Although I'm done, I should just stop here, but let me just test 0 to see if it will work. So test for 0 now. Test for 0. Fix 0 into the quadratic inequality. X squared minus x minus 6 is greater than 0. So anywhere there's x, I'm fixing 0 there. 0 squared minus 0 minus 6 is greater than 0. Of course, 0 squared is 0. 0 is nothing also, so I'm left with only this. Minus 6 is greater than 0. Is it true that minus 6 is greater than 0? Definitely not. On your number line, minus 6 is still far back, and your 0 is here looking at you. So 0 is greater than minus 6. So this is false. It is not true that minus 6 is greater than 0. So I will not include this region. So I have my answer looking at me here. So on this part, on this number line now, the arrow is going this way from minus 2, and it's going to the left. Less than means the numbers at this part are less than minus 2. So I have x. So let me write it out. X. Okay, let me use a blue marker for that. I have x is less than minus 2 here. Then here x is greater than 3 because it's going this way, showing numbers that are greater than 3. X is greater than 3. Then combining the inequality, write this, or the smaller one first. X is less than minus 2 and x is greater than 3. You could combine into a set builder. So start with the smaller value, minus 2. If x is less than minus 2, it means minus 2 is greater than x, and then also greater than 3. So that's it. These are the range of values that satisfy this quadratic inequality. Very simple and interesting.